Hey guys, it's Roya, and today I'll be talking to you about the total position equation, or the final position equation. Now, say we have a pebble named Sandy, and she starts at position 0 and decides to roll along in a straight line to the right. So that's her direction, and we want to find her final position. Now, if she has constant acceleration, her velocity versus time graph is going to look like this. Now, as we learned, her total change in position based on this graph is going to be the area under this triangle. And instead of using position in this case, let's use acceleration. Instead of using velocity, let's use acceleration. We know that the area under this triangle is the same as 1/2 AT squared. And this is what we learned in one of the previous videos, in case you're unfamiliar with this. So 1/2 AT squared. And let's say that 1/2 AT squared is a positive number, and that's going to be her final position. Now, what if Sandy were starting with an initial velocity of, say, 10 or 20? Then her her velocity versus time graph is going to look like this if she has constant acceleration. It's going to start at an initial velocity. Therefore, in addition to this triangle right here, which is 1/2 AT squared, we also have this area down here, this rectangle. And to find the area of this rectangle, we use initial velocity, VO, times time. So we have to add initial velocity times time in order to get our final position. Now, say that Sandy doesn't start at position 0. Say that Sandy starts, at position 10. She starts somewhere other than 0. Then we'll have to add her initial position. Now keep in mind that this equation right here, this whole entire equation, does not talk about change in displacement because we have initial displacement. We talk about, this is her final position. Therefore, if she starts at position 10, she's going to increase her distance to the right, or her position to the right, by 1/2 AT squared, plus initial velocity times time, plus her original position, which was 10. And this x is going to be her distance from the starting point.